Okay, so we're now going to start looking at how we're going to use our linear models when we have categorical variables within it. So the first thing I want to discuss is how do you actually represent categorical variables in R. So let's think about this data. Let's assume I have 5 statisticians. For each one we have their name, their pet, and how happy they are. And maybe what I'd like to do is I want to see if happiness can be predicted by the type of pet you have. So let's think about how we can enter that in R and then how R is going to represent it under the cover. So here's my data. The first thing we'll do is we will load some libraries we're going to need, and I'm just going to create some data. So we can see here is my data. So each row is a statistician. First column is their name, second column is the pet, and the third is their happiness. And at the moment you can see the pet, which is a categorical random variable, a nominal categorical random variable, is just represented as a character. And we know that we can convert it into a categorical variable by saying factor. But what's that actually doing? So let's run it. And then what I'm going to do is I'm going to use a function from the modeler package called model matrix, which will show me the design matrix I would get if I decided to use a regression with pet as a predictor. So let's have a look at it. So what we've got, if we come down to the design matrix, is first of all, like all design matrix, it has a column of ones, which is our intercept. And then the second column says pet, dog. And this is just a very simple column that only has the value 0 or 1, and it will have the value 1 if that person has a dog. So we know that, for example, Ty and Gary both have dogs, and so they have a 1 in row 1 and 5. So 4 and 5. Fine. What about this one, pet, rabbit? So here you can see this 1, and this column again will have 0s or 1s, 1 if you have a rabbit, and 0 if you don't. And the only one who has a rabbit is the first person, it's me, and it's Jono with a 1. So where's the third pet? Where's cats? Well, what it does is it takes the first level of this categorical variable. So it's got 3 levels. It's got cat, dog, rabbit. It takes the first one alphabetically, in this case cat, and it basically says that will be what my intercept is. So what that means is those that have a cat have an intercept and nothing else, because they don't have a dog and they don't have a rabbit. And so the sort of logic says, if you don't have a dog and you don't have a rabbit, you have the one that's left over, which is a cat. And this is called a reference class or reference level type way of representing categorical variables. What it means, and we'll see this when we do one way and over, is when we come to interpretation, we're going to get everything compared to the reference level, in this case compared to a cat. Okay, so that's how we represent it in R. There's other ways you can represent it in R, that's the default one. We choose the first one alphabetically, that becomes the reference level, and then we add an extra column for every level above that. So let's have a look at that. So if we have a predictor, x, with k levels, I'll represent this as k minus 1 binary variables, where the xij, so the value we get will be 1 if x is, for the ith individual, is at level k, and 0 otherwise. And as I said, the final level will be all the zeros and will be the reference level. Okay, that's it. Thank you.